Alright, so now it's time to create our second microservice, that is the order service. So for that, I'm going to open the website start.spring.io, and here, as we did for product service, we're going to select the Maven project, and we are going to select the latest Spring Boot version. The group ID is going to be com.techie.microservices. Artifact ID is going to be order service. And let's give the package name as com.techie microservices.order. I will leave the packaging as jar, and I'm going to select Java version as Java 21. Coming to the dependencies, I'm going to add the dependency for Spring Web, and I'm going to also add dependency for Lombok. I'm going to add the dependency for Spring Data JPA. As we are using a relational database, we are going to use Spring Data JPA with Hibernate. And for the database driver, as we are using MySQL, I'm going to choose the MySQL JDBC driver dependency, and I'm also going to add the dependency for test containers because we are also going to write integration test for the order service. And finally, we are going to also add a dependency called as Flyway to run database migrations. We will discuss what is database migrations and why we have to use this in the coming sections. So once this is done, just click on generate and the source code will be downloaded to your machine. Alright, so I opened the order service source code in IntelliJ IDEA, and the first thing I'm going to do is to download MySQL to our machine using Docker Compose. So for that, I'm just going to right click on the root folder, and I'm going to create a file called as docker compose.yaml. Similarly of how we did in the product service, I'm going to create a version as 4, and here I'm going to create an object called as services, and I'm going to create a service for MySQL. And here you can see that GitHub Copilot is automatically suggesting me the necessary Docker Compose configuration. So let's use that and make some changes. So for the MySQL image, we want to use the same MySQL image, but I want to use a different tag, so the different version. So I'm going to use the version 8.3.0, and the container name, I'm going to leave it as MySQL. This restart field, so I'm going to remove this. I'm also going to use the MySQL root password environment variables. So I'm going to define this as MySQL, and I don't need these 3 environment variables, so I'm going to remove them. And the port, I'm going to leave it as 3306 because this is the default port where MySQL will be running. And the volumes is going to be the MySQL folder. So whatever metadata which is created by MySQL database will be stored inside the MySQL folder in the order service project. So now let's go ahead and start up the container and see if this Docker Compose configuration is working or not. So I'm going to open the terminal inside the same folder as the Docker Compose file, and I'm going to type the command docker compose up -d. And you can see that as I already have this particular version of MySQL Docker image inside my local registry, it's directly went ahead and started the container. And if you don't have this image, you can expect a slight delay because Docker will first download this image and then will start up the container. So the next step is to configure MySQL in our Spring Boot project. So for that, I'm going to open source main resources folder, and I'm going to open the application.properties file, and here I'm going to type in the property spring data source.url. So this is going to be the JDBC URL of our MySQL database. So I'm going to use JDBC MySQL localhost 3306, and I'm going to define the name of the database as order_service. I'm going to define Spring Data Source username as root and Spring Data Source password as MySQL. So this is the same value we have defined here inside the Docker Compose file. So I think we have one typo here, so it's going to be Spring Data Source username. So the next thing I want to do is I want to set the Hibernate DDL auto property. So this is going to be none. So this will disable the DDL handling for Hibernate. We are doing this because we want to do all the database migrations through Flyway. And the last property I want to add is I want to run the server on the port 8081, because by default Spring Boot will run the application on port 8080, and we already have the product service running on that port. So we want to run the order service on the port 8081. All right. So now let's go ahead and try to start the application and see if we are able to connect our application to the MongoDB or not, to MySQL database or not. So I'm just going to run the application on the debug mode. All right, so we are getting an error. Let's see what is the issue. So we see Java SQL syntax error exception, unknown database order service. And problem is Hibernate is not able to find the database with name order service inside our MySQL database instance. So to fix this issue, we can either create the database manually by connecting to the MySQL database using software like MySQL Workbench. So here, if you go to the mysql.com/products/workbench URL, you can download this MySQL Workbench IDE, where you can write queries and then view the database. Either you can download this and you can create the database manually, or we can directly write SQL script and add this SQL script to the Docker Compose file, so that this SQL script will be executed automatically during the startup of the MySQL database container, right? So for that, let's create a new folder called as Docker inside the order service. And in here, I'm going to create another folder called MySQL. And in here, I'm going to create a new file called as init.SQL. So here I have to write the SQL command to create the database. So I'm going to write create database if not exists order underscore service. So we want to create the order service. So I'm just going to write the create database command to create the order service order service database. So now let's enhance the Docker Compose file to add this init.SQL file into the container which is running the MySQL database. So for that, I can add a new line here, and I can reference the Docker MySQL folder and the init.SQL file, and I want this file to be added to the /docker entry point -initdb.d/init.SQL file. So the Docker entry point is the command which will be executed whenever the MongoDB MySQL database container will be running, right? So in this way, our init.SQL file will be executed whenever the MySQL database container is starting up. So after adding this command, what I can do is I can run the Docker Compose one more time, Docker Compose up -d, and you can see that the MySQL database is running. Now, if we can verify if our command is executed or not by opening Docker. So if you open the Docker dashboard, here you can see the order service which is running. So I'm going to expand the menu here, and I'm going to click on MySQL. And if you check the logs, you don't see anywhere that the SQL file is executed, right? That's because our volume actually is already created. So we have to first delete this volume to make sure that the data is initialized correctly. So I'm going to add again Docker Compose down. I'm going to stop the MySQL container, and once this is done, I'm going to run again Docker Compose up -d. So if you open the MySQL container one more time, you can see some more logs, and in here you can see that the entry point Docker entry point initdb.d/init.SQL is running, and the initialization has started, right? So if you now open the MySQL Workbench, so make sure you download this MySQL Workbench to actually, make sure you download this MySQL Workbench based on your operating system to make sure that you can view the database and then run queries of the on the database. So I'm going to open the MySQL workbench, and in here I'm going to create a new connection. I'm going to provide the host name. I'll leave the host name as it is, which is pointing to localhost. I'm going to provide the port as 3306. The username, it's going to be root, and I'm going to provide the password, whatever password we have added inside the Docker Compose file. Let's add it here and click on OK. So once this is done, you can test your connection test your connection. I've already created my connection before, so I'm just going to click on this so that the connection will be established to my MySQL database. So once the connection is established, you can go to the schemas tab, and in here you can see that the order service is created successfully. You can see the order service database. Now let's go back to our application. So order service application, and run the application one more time, and you can see that the application is starting without any errors. So now let's go ahead and create our model class. So for that, I'm going to click on the root package, and I'm going to add a new package called as model, and in here I'm going to create a new entity called as order, right? So as this is going to be a Spring Data JPA entity, I'm going to add the entity annotation from jakarta.persistence package, and I'm going to add the table annotation, and I'm going to provide the name of this table as t_orders. So I'm going to add a getter annotation, a setter, and I'm going to also add an allogs constructor and noargs constructor. Coming to the fields inside the order class, so the first field I'm going to have is like an ID, which is going to be a unique identifier, which is for our primary key, and I'm going to add the generated value annotation, which is a strategy type of identity, and this is going to be a long ID field, which is pointing to our primary key inside our order table. The next field is going to be an order number, so it's going to be of type string. We also have a field called as SKU code. We'll have a field called as price, which is going to be of type big decimal, and the last field we're going to have is a type of integer called as quantity. So we are going to maintain a very minimum data model because we'll be mainly concentrating on the microservices architecture. That's why our services doesn't have any huge business logic. So I'm going to keep everything very simple. So we just need this one model field. So the next thing we are going to need is a repository to store this model. So I'm going to click on new Java class, and this time, instead of creating the package manually, what I'm going to do is I'm going to type in the package name inside the Java class itself, and the package name is going to be repository, followed by the repository I'm going to create. So this is going to be order repository, and this is going to be an interface, not a class. So I'm just going to press enter, and you can see that this interface is automatically created inside the repository package. So this order repository is going to be extending JPA repository, and this JPA repository is for the model for a class order, and this order class contains a primary key of type long. So we have our order repository, and the next thing we are going to create is like order service. So I'm going to do the same thing here. I'm going to create a package called as service.order service, and this order service is going to have the service annotation from Spring Boot, and I'm going to, inside this order service, I'm going to create a method called as place order. So I'm going to be public void place order, and this place order method will be taking a method, will be taking a type, a parameter of type order request. So this order request, we don't have it yet. So let's create this order request as a record, Java record. And this is going to be in a package called as DTO. And in this order request, the first field is going to be ID. So this is going to be long ID. The next field is going to be order number. The next field is going to be SKU code, followed by the price. And lastly, we have our field called quantity. So this is going to be a plain old Java record. And let's go back to the order service. And in here, what we have to do is we have to first map order request to order object. and then save order to order repository, right? So that's what we want to do inside the place order method. So to map the order request to order object, I have to first create the order object. So first I have to create the order object. So this order is going to be from the model package equals new order, and I'm going to set order dot set order number as a UUID dot random UUID dot toString, because we need to create a unique order number. And the next one is going to be the price. So I'm going to map the price directly from the order request. So I'm going to type in order request dot price, and in here I'm going to next map the field called SKU code. So there's going to be order request dot SKU code. The next field is going to be the quantity. So order dot set quantity should be from order request dot quantity field. So this is all the fields we have for the order object. Next, we have to save this order object to the order repository. So for that, we need to inject the order repository into the order service class. Let's do that by adding private final order repository, and we need to add a constructor for this order repository. So let's add the required args constructor from Lombok, and let's come inside this place order method, and in here I'm going to type order repository dot save order. So let's remove this comments, so not so useful. So now we have the place order method ready inside the order service. The only thing which is remaining is to create the order controller, order REST controller, where we have the REST endpoint where our clients can call. So before we go ahead and just remove the unused imports, and now I'm going to create a new Java class in a package called as controller, and the name of the class is going to be order controller. And on top of this class, I'm going to add the REST controller annotation, and with the request mapping annotation as /API/order. And let's also add the required args constructor annotation, as we are going to inject the order service. And the endpoint we are going to create is going to be a post mapping endpoint, and this is going to send back a response status dot created, and the name of the method is going to be public string place order, and this is going to take a request body of type order request. And inside this method, I'm going to call order service dot place order, and I'm going to pass in order request as the argument, and I'm just going to return a string called as order placed successful. So this is all we need to create the endpoint to place the order. So before we go ahead and start our application and do the test, we need to do one last thing. So if you open the application.properties file, you saw that we saw that the Hibernate DDL auto property, we have set it as none. If we set it as create, what it will do is it will create the schema and destroy the previous data, and it will also create all the necessary database tables automatically. But we won't want to use this option usually on production grade environments. So what we can do instead is you can set the disable DDL handling option by choosing the option none, and we can create the tables and do all the database migrations using a special library called as Flyway. So the main advantages of using Flyway is it helps us to version control our database so that we can run the migrations easily. So imagine that I have one database table called order, and like some months down the line, I want to add a new field inside this table. So what I will usually do is I will add this field inside my Java class, and the migration and updation of the database table usually happens as part of Hibernate, right? And if there is something went wrong while creating this new additional field, there is no easy way to roll the database back to its previous state, right? By using the Flyway database migration tools, we have the option to migrate a particular database by writing our own SQL queries. And we also have the option to roll back to any previous versions. We also have another library called as Liquibase, which is widely used database migration tools. So in our project, we'll be using Flyway, and we have already added the necessary dependencies inside the pom.xml. So if I just scroll to the pom.xml of order service, you can see that we have the dependencies Flyway core and Flyway MySQL to add the support for MySQL for Flyway. And our database migration scripts will usually be stored inside the dp/migration folder under resources. So Flyway, whenever it's initialized, when it's running, it will look for the database migration scripts inside the db/migration folder. Before starting the application, as I mentioned before, we have to create the database table for the order entity. So for that, I'm just going to click on the db.migration folder. I'm just going to click on new file. And in here, we have to follow a specific naming convention whenever we are writing migration scripts for Flyway. So the naming convention is going to be, it should start with a capital V for version and a unique incremental number. So for example, I can write V1, and it should have the prefix symbols as 2 underscores, right? So have V1 underscore and underscore, and then you can have the name of your file. So it's going to be init.sql. So in here, you can write your database migration scripts. So for our use case, I already have one SQL query ready. So what I'm going to do is I'm going to just paste this SQL query. And what we are doing here is we are creating a table called as t_orders. And inside this table, we first have the ID field, which is like a primary key, which is going to be auto incrementing. And next field we have is a order number, which is like a varchar, and the SKU code, which is going to be another varchar. And we have another field called as price and quantity. And of course, we have added the ID also as a primary key. So we want this table to be executed for the first time when we are running the Flyway migrations, when we are running our application. If we just go ahead and run the application, and I want to stop and rerun. So if you observe the logs, you can see that the current version of the schema order service is empty, and the Flyway recognized that there is one migration script to be executed. So it has actually resolved the name of the migration script as the number of the migration script as 1 and the name as init. So it started executing our migration script. You can see that log successfully applied one migration to schema order service, now at version V1. So our database is now at version V1. And if we want to add one more field, what I can do is I can right click on DB migration, and I can click on a new file. This time I have to create a new file called as v2 __ add column.sql, and I can write my logic to update or add some column. So in this way, we can have database migrations in a specific order, and we have all the changes in our database version, just like we version our source code using Git. We can also version our database changes using Flyway, right? So for now, we don't need this SQL file. We can just stay here on version 1. So another question you may have is, if I rerun the application, what happens? Will this file be executed again? Let's see if what is the case. So I've restarted the application, and you can see that Flyway has successfully validated one migration. It already maintains the state of all the migrations which were executed before. So it saw that the current version of schema is 1. So that's why it skipped migrating the version 1 of the migration script one more time, right? So if I add version 2, then it will start executing. But as version 1 is already executed, Flyway is smart enough to skip this particular migration script. And you can see the logs that schema order service is up to date and no migration necessary. So our application startup is going to continue. And this is how you usually use Flyway. So let's verify if the database tables are created successfully or not. So for that, I'm going to open MySQL Workbench, And in here, I'm going to select the order service schema, and I'm going to right click and click on refresh all. And now you can see that we have some tables. So the first table is the Flyway schema history. So if I just right click and select the select rows option, you can see that it has saved the name of the migration script. So it's v1__init.sql. So it's maintaining all the history of the scripts which are executed inside the Flyway schema history table. And now we have, and then we have the t_orders table, which we created as part of the migration script. And we have our all the columns we added inside the SQL script. This is fine. So now let's go ahead and open Postman. So now I've opened Postman to test the REST endpoint to place the order. So for that, I'm just going to add the request URL has HTTP localhost 8081/API/order. The request method is going to be post, and we have the JSON with SKU code as -15, price as 1000, and I'm going to put the quantity for now as 1, and I'm going to click on send, and you can see that we got back the response, order placed successfully. Let's verify if the order is really saved to our MySQL database or not. So I'm going to again open MySQL Workbench, and I'm going to right click on t_orders table. I'm going to select the rows, and indeed you can see that the entry is really saved to the t_orders table. That's good. This is fine. We have implemented the REST endpoint and tested it manually. So now let's go ahead and write some integration tests. In the previous part, I've showed you how to write one integration test for the product service. So for this part, I'm going to refer you to the written tutorial of the Spring Boot Microservices tutorial series. So here, if you search for integration tests for order service, you can see that I have the necessary code for the integration test and how to write the integration test for the order service. So you can refer to this blog post if you are stuck. So first, I suggest you to write the integration test on your own. And if you are stuck, you can always refer to this integration test from the blog post.